All right, now we're going to start looking at multiplying and dividing rational expressions. And this corresponds to example 4 in your textbook on page 531. And I'm going to do the multiplication first and then do the division in a second video, just because of what the length of the video may be. And this is where it gets to be a little bit squirrely or a bear or whatever. You may want to say again, it's not that it's that hard. It's not that you don't have the skills to do it. You do. It's just easy to make a mistake, and it's real easy to get things jumbled up um, when you're solving them because you got so many pieces to it. Now, I'm going to work these two different ways. We'll kind of discuss why I do what I do. But here we got 12c cubed d squared over 21ab times 14a squared b over ac squared d. And it's just like anything else. When we're multiplying rational expressions or fractions, it's numerator times numerator, denominator times denominator, and we're going to deal with like terms. So let's see. I'm going to start off with 12 times 14, and I am using my calculator as I go along. So that's 168. All right, and then c cubed. I don't see a c term in the numerator on the right side of this. So we got c cubed. And I don't see a d squared or d, so I got c cubed, d squared, a squared, b. Now that's a mouthful. All over, well, let's do 21 times 8. Well, Shazam, that happens to equal 168 too, as well, I mean. Okay, and then we got AB, C squared, D. Now, so our 168s are just going to cancel. That's just going to reduce down to 1. So let's see, I got a C cubed in the numerator and a c squared in the denominator. Of course, when we divide exponents, we subtract the exponent. So the c squared is going to cancel, and it's just going to leave me c to the first power. And I like to put that 1 up there, make sure I don't cancel the c itself. I got a d squared over a d. Well, the d is going to cancel. It's going to leave me with just d. And I got an a squared in the numerator and an a in the denominator. And so the a down here is going to cancel. It's going to leave me a to the first power. And then I've just got a b to the first power both in the numerator and the denominator, and those cancel. And so my final answer is c to the first power, and I'm not going to write the 1, d, a. Or I could say ACD if I wanted to put it alphabetical. How about that? Maybe that looks better to your eye. ACD. We know that CDA is going to equal ACD. Same thing. Okay, well that's that. Now let's look at the next one. We got 6xy over 15ab squared times 21a cubed over 18x to the 4th y. Now, I could do some reduction between the 6 and the 15, and or I could look to do some cross multiplication. So let's do that. Now, I don't like this method as well because it makes me confused, but you may prefer it. Well, this 6 is going to go into the 18 3 times. That's going to make that 1. And I've got an x up here which is going to cancel, going to leave me with x cubed. And the y's are going to cancel using cross multiplication. This is before I go numerator, numerator, denominator, denominator. Now 3 is going to go into 15 5 times. And it's going to go into 21 7 times. And this a is going to cancel and leave me with a squared. And the b squared is going to remain the same. All right, now we're going to go numerator times numerator, denominator times denominator. And so I'm going to end up here with, well, 1 times 7a squared is just going to be 7a squared over, well, 5 times 3 is 15. Those are like terms. And I got b squared. And see, I'm just about to not see that x cubed right there. That's why I don't like doing it this way. X cubed, and that was b squared, wasn't it? B squared x cubed. So my answer is 7a squared over 15b squared x cubed. So I did a little bit of cross multiplication in that before I actually multiplied it. And like I say, I mean, you may prefer that because it gives you a little bit smaller numbers, and it was a little bit better multiplying 1 times 7 rather than 6 times 21 and 5 times 3 rather than 15 times 18. But hey, that's what calculators are for. All right, next up we'll do some dividing rational expressions.